Okay, hi everyone. So this is our last week of class, and this is for me the time where I can pull everything together that we've been doing for the last 4 months. We started doing with Pythagorean theorem and trig. We went into 30, 60, 90 triangles, 45, 45, 90 triangles. We put them on the XY grid. I taught you about angles in standard position, coterminal angles, and reference angles. And here it is. Without using a calculator, you'll be able to find what is sine of 150 degrees. And this is kind of the culmination of 4 months worth of work. So today I will hopefully explain this well in this video, and then in our live online class, we'll do a little bit of practice, and I'll answer questions and just review a little bit more, and then that'll be it for the whole year. So just as a quick review, here is our unit circle, and we have, this is 0, 0, and as we go out, that is the point 1 comma 0. How do we know that? Because a unit circle has a radius of 1 unit. So when we go up, we didn't go left or right, so it's 0, and then you go up to 1. Now here on the XY grid, it's still 1 unit distance, but when we move to the left, we indicate that left movement with a negative 1 for the x, and when we move down, even though that distance is a unit of 1, we indicate that point by negative 1, just like there's nothing new here. And for angles in standard position, we have the initial ray is always the positive x-axis. And if I draw the terminal ray here, that could be a lot of different angles because of coterminal angles, but if I draw this loop here, then you know that this just went around halfway around the circle. That's 180 degrees. Or if I continued the loop this way, it would be 360 degrees. Okay, just as a quick review. Okay? So now here's an angle in standard position. We always have that initial ray there. Here is the terminal ray, and this makes an angle of 45 degrees. So it's halfway between 0 and 90. And then this is what you guys did 2 weeks ago. This point of intersection from the ray to the unit circle, well, we want to know what is the x and y of that point. Why do we want to know? Well, it all comes down to this. From this circle, we drop a perpendicular line to the positive x-axis in this case, and we have a 45, 45, 90 triangle. 45, 45, 90. And we know that this is length 1 because it's a unit circle. So what is this length and what's this length? Well, you guys remember, you can do it using sine, or you can just say, well, this is x and this is x. Pythagorean theorem, 2x squared equals 1. When you solve for that, you get x equals the square root of 2 over 2. Once you simplify. So that means that this length is square root 2 over 2, because that's what x equals, and this height is square root 2 over 2. Yeah? So we know now that this is square root 2 over 2, square root 2 over 2. And the cool thing about the unit circle and angles in standard position is this is the cosine of 45 degrees, and this is the sine of 45 degrees. Now, I don't think all of you really have really processed this yet. Some of you have. I'd say about half of you, I feel confident that you understand this. About half of you are a little shaky on this. Why? Because cosine is, sorry, I just want to change color. Cosine is this adjacent side divided by 1. Well, it's just that. Just the length of the adjacent side. Sine is the opposite length. This length divided by 1, well, it ends up just being that. Yeah? So if you don't understand that, please just review old lessons, or you can look at videos, search for videos online. So here is our triangle in the unit circle. And remember, in quadrant 1, cosine, here's sine, and they're both positive because all points are positive in quadrant 1. And here cosine of the angle is x and sine of the angle is y. I should say cosine of the angle and sine of the angle. Okay? And this is kind of just what I did with this triangle. Square root 2 over 2, square root 2 over 2. Yeah. Okay. So now the new stuff. That's all review, and here we go. So now what I want to look at is this angle of 135 degrees. And up here I'm going to put a box. And without using a calculator, you now have enough tools to tell me what is cosine of 135 degrees and what is sine of 135 degrees. So let me explain how you can do that. So what we're going to use here is this idea of reference angles. Because the reference angle, if you remember, it's how much further from this terminal ray do I need to get to the x-axis. And in this case, the reference angle is 45 degrees. So now I'm going to make a triangle, or they made a triangle already here. And if you look, this is an exact duplicate of this triangle. How do I know that? Well, this is 90, this is 90, this is 45, and that's 45. So that other angle is 45. And then the hypotenuse is 1. So now we have two identical triangles. So this length here is square root 2 over 2, and this height here is square root 2 over 2. What's this point? Well, remember on the quadrant, in the Cartesian plane, when we move left, we represent that with a negative. And when we go up, it's positive. So in this case, it's still the exact same numbers from sine of and cosine of 45 degrees, but now we have to think, are we in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Because if we're in quadrant 2, which we are with 135 degrees, this is going to be negative. The x term is negative. So now, when we have reference angles with reference angles of 45 degrees, the number's not going to change. It's always going to be square root of 2 over 2, but we have to decide, is it going to be positive or negative? Cosine is negative in quadrant 2, and sine is positive. And so you can look that up in your calculator now. You can type this in. You know, this doesn't give you a nice, I mean, some calculators will write square root 2 over 2, but you'll get cosine of 135, you'll get negative 0.707 something something. And sine of 135 is positive 7.707. Pretty cool, huh? All right, next one. Now we're going to have a reference angle from here to here. Our angle in standard position is going to be 225 degrees. So I'm going to put in my little box up here, I'm going to put cosine of 225 degrees, sine of 225 degrees. Well, these all are carefully chosen numbers that have reference angles of 45 degrees. Because in this case, because we're in quadrant 3, we have to take 225 degrees, subtract 180 degrees to know what that reference angle is, which is 45. And again, we can draw a triangle that's an exact duplicate of this one and this one. I hope that makes sense to you why that's true. These are right angles. The hypotenuse is 1. So that's the exact same distance out from the origin and from this endpoint up, or in this case, down to the point. In quadrant 3, both x and y are negative. So we have the same lengths, but now they're both negative. And type it into your calculator. Type in cosine 225. You'll see that you get negative 0.707. Sine of 225, you get negative 0.707. And it comes down to these reference angles and these equilateral, these congruent triangles. Last one. And then from here we go all the way around. And now we're looking at the angle of 315 degrees in standard position. Yeah. So I'm going to draw the box here and do cosine of 315 degrees and sine of 315 degrees. And again, I mean, you can see it's kind of pretty. We have these, you know, these congruent triangles here. Now we have 4 of them. The reference angle of 315 degrees, we do 360 minus 315 degrees, and you get 45 degrees. So yeah, the reference angle is, here, I'll do an eraser here. It's getting kind of messy. So we have 315 degrees. Here's my triangle right there. This length is square root 2 over 2, and that's positive. We're going in a right motion from 0, 0. So cosine is positive in quadrant 4. Excuse me. And sine, because from here, from the x-axis, it goes down, it's negative. So cosine of 315 is square root 2 over 2, and sine is negative square root 2 over 2. And that is all I'm going to talk about today. And in the live class, we'll do this with the same thing with 30 degrees and 60 degrees, and then just have you guys do some practice. But the important thing to notice here, you have to remember in quadrant 1, x and y are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. Quadrant 4, x is positive and y is negative. And we get this really nice kind of shape here with these congruent triangles. And it all comes down to these intersection points on the unit circle. Okay, so if you need to, you can review this video, watch it again, or you can go online and watch other videos. You can email me questions, or we can talk about this on our live class on Thursday or Friday. Okay, thanks so much, guys, and I'll see